So let's get underway with the session. Welcome everybody to today's webinar. There's a great turnout. It's really nice to see everybody here on a Monday afternoon. We really appreciate everybody who's made the time to come along today. And it should be a really interesting session for all of us, learning a little bit more about Scratch and particularly about teaching Scratch in the context of the digital technologies curriculum. I'd like to introduce myself. My name's Nicola O'Brien. I'm a member of the team here at the ACA with a special interest in primary school education. I have a couple of hats that I wear at the ACA. One of those is leading the teacher engagement efforts. So please reach out to me anytime you're looking for classroom ideas or have questions about using any of our resources. I'm happy to help. I also develop online content for the ACA. So the Scratch courses that we'll look at today were made by me. So again, send the bug reports my way. I can fix them pretty easily. And I also run PD sessions, obviously. Here I am this afternoon. And I'll pass across to Penny, who's joining us today, who's another great member of the team.
Yep, I'm coming at it from the engineering side. So I'm one of the digital systems experts at the ACA. And I narrated some of the Scratch courses recently. So you'll be hearing my voice on them if you try them out.
That's right. It's sort of peeking behind the curtain, isn't it, Penny, showing what the ACA team's about. So we will use the annotation a little bit today in the webinar. You're now viewing my screen, and up at the top left it says View Options. You can click on there and say Annotate. So we'll get some feedback from you both on the screen with annotation, in the chat channel, and possibly in some Scratch projects too. So while we get underway, I'm going to start off, there's a link to a Scratch project, cmp.acely, I'll just put that up again, /Scratch1.
I'll put it in the chat as well.
Thanks, Penny. This is a project that we made to collect data using Scratch. So you can see that Scratch project up there now. Just one of the ways we wanted to give you some ideas for how you might use Scratch in the classroom. If you're used to using Scratch mainly as a way to make games or animations, there's a lot more you can do. So if I have a look on the project page for this, when I click the green flag, you can see these little bubbles with the states move around a little bit. Anyone who's in the project, go ahead and click on the state that you're coming from today. So I can click on New South Wales. And you can see that New South Wales actually moves up the screen when I click on it. I know that Penny's been in here before. She clicked on Tasmania, and that's moving up the screen. So what we're doing with this particular project is we're gathering some data from you as users. You can click on your state too. We're gathering data, we're also representing data on screen. So the more votes we have for a particular state, the further it travels up the screen. So that's a nice project that you can replicate. And the bottom part of the screen is a way of getting information about how everyone's feeling today. And of course you can jump in the chat today, but if I click on my chicken, let me know how you're feeling. Enter a number from 1 to 10. I'm feeling pretty good today. I've just had my second Coke Zero. So here we go. And our group's average score is up to about 8.26. So obviously what I'm doing there again is gathering some data. I'm aggregating some data and working out the average feels in the group today. We are great. So when we started, it said we were good. And now we're up to great. So we have a way of getting, and again, representing data in a different way. Welcome, Maria, and I'm sorry I didn't have Argentina as an option for you. Apologies. And it's really great to have you here from another country too. We hope that you get a lot out of today's session. So let's have a think about what we're doing today. The focus is on Scratch, but as I mentioned, what I really want to get into today is talking about the digital technologies curriculum and how we go about using Scratch to teach programming in our classrooms. So at this point, if you have your annotation tools open, please jump onto the screen that I'm sharing and let us know what you think Scratch does for you. Do you think of it mostly as a programming language? Do you use it as an animation tool, maybe a sandbox? Let us know how you're using Scratch. Put a cross by things you definitely wouldn't have thought of it as, and there is lots of white space on the screen too. So if you're using Scratch in a different way, go ahead and type on the screen how you might be using it. And we're going to have a look at these different uses of Scratch and how that sort of can create challenges, issues, and benefits for us using Scratch in the classroom. So most of us are using Scratch as a programming language. Hey Penny, if you've got a way to screenshot this, that would be great.
Yep.
An assessment tool, and someone else as a game. Yeah, there are a lot of games on the Scratch website. I've got crosses and question marks around the social network, but I will talk about that a little bit today. And a lot of us are using Scratch for animation. Excellent. Scratch is all of these things. Let's talk about them. So a programming language is obviously what we'll focus on today. A gaming platform, for a lot of students, their first introduction into Scratch is looking at it as a place to play games and create their own games. So that's certainly true, but Scratch also, as you can see hopefully from that first project that I shared, is also a lot more than just a programming language. Now, if you're having issues hearing, just turn up. I think everyone else can hear me okay. Penny, you can hear me fine, can't you? Yep, okay. Maybe check the volume settings or Bluetooth speakers if you're having trouble. The reason I put social network on there is it's very important to know if you're using Scratch in your classroom, if your students are going onto the website and creating an account, they are then able to share their projects on a public platform. They can comment on other projects, and they can like and favorite other comments, other projects. So really, although we wouldn't think of it as a social network, it is. And with that comes the responsibility of behaving responsibly on a social network. And for many students, particularly around the year 3-4 level, this might be the first time they've been able to look at other people's work and provide feedback. Now, as a teacher, I get comments like, oh, duh, what's this? You know, lame maze. I've had that a few times on one of my projects. And I'm okay with that, but I do always remind kids that leave unconstructive feedback, shall we say. You know, I'm a real person, you're talking to me, and it's very worthwhile spending time with your class before you go online to talk about what that means, to have that power to comment. And even if you ask students not to share their own projects, they will still have the ability to look and comment on other students' projects. So it is really worthwhile keeping in mind that you might be the teacher that introduces students to their first social network and the responsibility that comes with that. Obviously, there are offline versions of Scratch, and that might be a path that you choose to go down, that you prefer not to be in the online environment for that reason. For anyone who's joining us late now, if you wouldn't mind switching off your cameras, just because we're streaming live on Facebook and we're also recording the webinar, so preferably cameras off, please. Now, in terms of why Scratch is the way it is, just a quick note here, and let me clear my screen of annotations. Okay.
Got it.
Thank you. Scratch is a programming language that was developed some time ago in the US at MIT. And if you're wanting to get into the theory behind Scratch and why it is the way it is, there's a great book that was published a couple of years ago called The Lifelong Kindergarten. And they use this idea of projects, passion, peers, and play. So Scratch is very purposefully an online environment that encourages exploration, encourages play, get in there, have a look, pull things apart, see what you like, and very importantly, have a look at what other people are working on, and remix, change, adapt. That is the whole philosophy behind Scratch. It's very much set in the project-based learning space. It's meant to be collaborative in terms of sharing and looking at other people's work. And that is why it's an open platform in the way that it is, in the culture of open source software, which, you know, as you become adult coders, there's a lot of sharing that goes on in the software community. It's not about explicit teaching. And so as a teacher myself, you know, I'm interested to know more about the pedagogy and how can we take this tool and use it in our classrooms to support learners, but also to make the best use of the time that we have as teachers. If you have a class that's studying digital technologies, how can you use Scratch in the most efficient way? And how can you use it to achieve the outcomes that you need to? And that's what we'll be talking about today. But I wanted to set the context of Scratch is intentionally open and very free form, a sandbox, as I said on the previous slide. And we need to learn about how to use that effectively to get the most out of it. Let's move on. Let me just put that away. Okay. Now, what does Scratch do well? And we'll look at some examples of all of these. Scratch is fantastic in terms of providing students with instant feedback. So when students work on a project, and I'll show some coding shortly, they can run the code repeatedly and they can see exactly what's happening and whether they're getting the success or the result that they want in their project. Let me open up a Scratch project and just show you what I mean by that. My inspirational message for the day. Okay. And for those who have, if you've never used Scratch before, pop a little comment on the chat. I should have asked at the beginning, sorry. Here's the Scratch programming language. For people, I'll give you a rocket speed tour for people who haven't seen Scratch before. Scratch is based around sprites. Here's a sprite 1, a cat or a character. There are lots of commands on the left-hand side where I can get the cat to do things. This is where I build my project. So I might move 10 steps, and then this is where I'll see the output or see what's happening in my project. So if I, for example, want to get the cat to a certain spot on the screen, I can create an object on the screen. So let's do this. Okay. If I give my students the challenge of saying, get the cat onto the cross, they might think, well, maybe that's a 10-step movement for the cat, and they can try that. No, it doesn't get me there. They can try it again. They can change how many steps the cat makes. They can return the cat to a fixed position and keep trying. They might want to see how many steps it would take to get to here. And you can see it's very simple for students to repeat instructions, try different things, experiment, and get instant feedback about what they want to do within a project. Now, the next bullet point I said was Scratch is very creative. So here's a cat. I can also come in here and I might decide that I want to make another sprite. I can straight away, I can design a heart. Terribly drawn, but I can make my own sprites using my own art. And then I can come across and give this heart some instructions. I might say, let's make it turn around. I might make it change color. And you can see that I can design step by step exactly what I want to happen. I can experiment, I can try different things. And I can, start to do things like this and go, wow, okay, I'm on the way. So this is what students love about Scratch. It's the creativity and it's the chance to experiment. And Scratch is very, very good for that. There's an expression, if you read the book I mentioned on the previous screen, that Scratch has low floors, high ceilings, and wide walls. That's the expression they used to say. It's the low floor. It's very easy to start making a project in Scratch. You can see back here, simply we've thrown some blocks together, we've made something happen, and we're pleased and we have our first success or our first win, which we know is really important with student engagement. It's got wide walls. What that means is that Scratch can go in any direction. If I'm interested in dinosaurs, I can make a project all about dinosaurs. I can inform you, I can delight you, I can animate dinosaurs. I'll be happy. And the student next to me with the same coding knowledge might be making a project all to do with a recent trip they did around the country. Maybe they want to document the different places that they had ice cream sundaes and tell you about what their favorite flavor was. They can do that using Scratch as well. So the wide walls refers to the many different directions students can go. The high ceiling, which we're going to talk about quite a bit, refers to the fact that students can take this programming a long way. It's a fully functioning programming language. So if Penny and I want to build a mechanism to sort numbers, display information in lists, and quite iterative, complex projects, we can do it using Scratch if we have the patience. And that's the high ceiling. You can go a long way. Unfortunately, as we'll see, high ceiling often doesn't come into play. Students don't progress very far, and we'll talk about that. The final point I made on this slide is that one digital technologies concept can lead to many, many project types. Let me know in the chat if you've ever built a quiz or something with your students, because I think that's one of the best examples. With some simple understanding of really key curriculum concepts, students can make quizzes, so they can use that to integrate with literacy or maths. They can make a project based around questions like a choose your own adventure story. They can go in lots of different directions, all with the same key coding ideas which have been taught to them. So that's really a great thing about Scratch, is that once the students understand concepts, they can then take them in many directions. However, with the positives, there's always, something to balance it. There are quite big challenges using Scratch in the classroom. One of them is collaboration. So Scratch is very open and you can share and remix projects. What is really hard to do in Scratch is to have 3 or 4 students work on a project together. You can't have multiple people in a project at the same time. You can do things like have different people share the username and password, but that's a bit like using Word docs 10 years ago before we got Google Docs. So you'd have to say, well, look, I'll work on it from 7 till 8 and then I'll sign out and you sign in and do something. It's actually quite hard for students to work together. So even though it's lovely project-based learning, keep that in mind when you're defining what you want a project to look like. Another challenge, signing in. Younger students can find it quite challenging to have the username and password. And also from a teacher's point of view, depending on the privacy requirements and where students can have accounts created, that's something to keep in mind. I do have a fix for you for that. We'll look at that soon on the Grok platform, but there is an account setup process involved. The other challenges, the third ones, are pedagogical challenges that we're going to talk about in more detail. So encouraging good coding practice, setting students up for high school and creating solutions. I'd like to talk about in quite a bit more detail, and I have some slides to talk about those coming up. So for now, I'll just plant those seeds. So I know Australia's top rating show is MasterChef. Someone asked if Scratch has single sign-on. That was something I wanted to investigate before the session. It doesn't have single sign-on that I know at the moment. I have heard a whisper that it might have a Google Classroom integration. But beyond that, other than accessing it through our platform, which I will show you, I'm not aware of an SSO feature. So here's a picture of the MasterChef kitchen, and I think it's a nice way to think about the Scratch language, that it's more of a pantry than a recipe. Now, you as a teacher might be happy to go, kids, go and explore, see what you find. And this might be the first stage of your teaching. Let's pull out blocks. Let's see what they do. Let's see what happens when we combine them with other blocks. Is jam good with spaghetti? Do we want to put olive oil with brown sugar? I don't know. Let's just try it and see. And that's what Scratch is like. It's like opening the cupboard. Now that's fun. And that might be perfectly fine in a lunchtime club or in some sort of extracurricular activity. If you're wanting to cover digital technologies outcomes, you might need to be a bit more structured in how you approach things. So maybe you want to have a play in the kitchen, pull out the ingredients, see what everything does, try different combinations. But then you want to move on and say, well, look, let's make a project together and be a bit more structured. Let's learn how to make cupcakes, or the Scratch version of cupcakes. And I've come up with my own sort of letter P, sort of playing on the Scratch idea. What would my P's be? And I'd say let's start with having a play and then let's plan. So once we understand what the blocks do, let's be purposeful and plan for what we want to achieve with the blocks, rather than just using them randomly. Once you have a basic skill, let's produce something. So let's purposefully set out to make a project that meets a required outcome. Then we can move on to personalizing, and let's make that our own. Once we've got the engine of a quiz, once we understand the structure of how you can ask questions and check if they're correct, let's personalize it at that point. So let's keep the students together, work on an idea, and then give them plenty of time to personalize it and put the different flavors of frosting on the cupcakes. If I can stick with that analogy, choose all of the sprinkles, do whatever they like. But once they know how to make the basic cupcake, then let's go and do something. And I do agree with Mitch Resnick that peers are very important in the classroom. Let's make sure there's enough time to have a look at what everyone else has worked on and have a try and provide constructive feedback. That is a really important part. So what you'll notice when I say it's more of a pantry, Scratch doesn't come with much in the way of inbuilt explicit tuition. There are a few starter tutorial kind of activities, but not a lot. And I do believe that it's really important to have some teaching and be able to work through things. I might skip ahead at this point because everyone's listening, but I'd like to get you doing. In the reading that I've done, there is a lovely way of teaching Scratch and teaching programming in general that I'd like us to have a look at. And that's an approach called PRIM, which stands for predict, run, investigate, modify, and make. And I think it's a really helpful way to approach Scratch. So I'm going to open a Scratch project now and we'll step through that process together and make use of the chat function. So get ready to type and we'll have a look at what PRIM looks like in practice. So let me think about the best way to do this. Okay, if we go inside and look at the code for this project, the first step of PRIM is predict. So rather than students starting with a blank page, we'd start by looking at some code together and thinking, what can we do? If anyone wants to jump in the chat, what do you think this code will do when we run it? And you can go as detailed or as high level as you want, but if everyone can jump in and start adding your thoughts about what you think this project will do when you run it, that would be great to see. And you would work through this with the students. Thanks, Sophie. Move the duck around and change colour. Absolutely. It will play a sound and say hello. So you can see straight away a really important part of digital literacy. It's not just making code, but comprehending code. And this first step of predicting allows students just to pause. Thanks everyone for coming in with your comments. I can see them flooding now. And have a look and predict what they think will happen, step one. The second step is to run. So once we have an idea of what will happen, we can run the code. Here's my chicken, moving around the screen and making sound. There we go. So for those of us who thought that was what would happen, well done. This is your chance now, if you didn't expect that outcome, to have a look back at the code, and that's the run stage. The next stage is investigate. And this is when with students, we pull things apart a little bit and we hone in on individual details. So we might say, oh, this box says change color. It's got a triangle here. What happens if I click on the triangle? And that's the investigation stage. So, oh, look what's opened up. We have different things here. We can make it mosaic or brightness. I wonder if we can change these numbers. Let's have a try. I wonder why we need to wait at this point here after we've gone to random positions. What's that block doing? And so we're now into the investigate and we're really thinking in a more granular fashion about what the blocks here are doing. It says play sound chirp. Oh, it says record. Okay. Beware of sound in the classroom. I'm not going to do a live recording today. And also we can investigate, we can change things. So the next stage of PRIM is modify. So at the modify point, I'm not sure what this wait 0.05 seconds does. What if I take that block out? Let's see what happens now. Oh, wow. Okay. That was really fast. I might put that back in. That said 10. I can be like everyone's favorite student and type 10 million. What's going to happen? I'll leave that for students to play with, but maybe I'll change it to 5. And what we're asking students to do here, before they have to start making projects of their own, they can take this project and change it. And this can become their own project. So they might want to say, my name's Nicola, and at this point they might like to start adding more blocks on. So as well as changing what's already there, maybe we want to put those at the beginning and start to modify the project and see it do different things. So it's a nice way for students to start to get that sense of creativity and being able to control things without having to start with a blank project. There's another sprite here, there's a hen, and there's nothing on there at the moment. It's up to the students. What would you like to get the hen to do? And the final stage of the PRIM methodology is make. Now, a lot of the time in the classroom, the temptation is to jump straight to make. And like, let's make a project. Let's start getting all these blocks and do things. Now that's fun. But I think if you sort of skip over those first 4 steps, for students, often they might be unsure of what they're doing and they might fall into what I call sort of block soup, or, you know, there's just a whole lot of blocks on the stage and no one quite knows what they do. And there's not a lot of purpose behind it. So I would really encourage you to give this methodology a go and just create some projects, look at some other projects, query them at not just a whole project level, but a block by block level to get a really nice understanding of what some of these blocks are doing before you start to make a project on its own. If anyone has any questions on that approach, feel free to jump into the chat. Otherwise, the next approach, I guess, that I wanted to show you in terms of teaching Scratch, we have created a number of courses which are available on our platform, which teach Scratch in a very sort of incremental step-by-step way, introducing blocks, explaining what they do, and getting students to follow a lot of those PRIM steps. So here are some blocks, change things, modify, let's have a look. I haven't opened them up today. I'll leave you to have a look at them, but maybe I'll jump across here and show you where, oh, I'll jump into one. Let's do it. So I'm going to go on our resources page and choose Scratch. They're aligned to the curriculum, which I'll speak about briefly, but if I go into get started, if you need any help getting signed up to Grok, please let me know. We can help you with that. These courses are free. So we are hosting a version of Scratch inside our Grok platform. That means the students, if they have a Grok account or they have single sign-on, which works with Grok, don't need to have their own Scratch account separately. And it also means they're not online in terms of commenting and sharing and so on. They're straight into the coding interface and working independently. And what we do is we have the Scratch interface that you're familiar with, overlaid with slides. And these slides, this is where you'll hear Penny's voice. She's narrated the courses. And they give the children explicit steps. So this is the very first question. And the first instruction is to drag blocks together and then click the green flag. And it shows that each time we click it, we move the sprite. So it's stepping right from the very beginning of what do these blocks do and why do we want them to do things, and having the children reflect on what individual blocks do within Scratch. So it's an explicit teaching wrapper around Scratch. And I'd encourage you to have a look at these in 2 contexts. One, if you're new to Scratch yourself, teacher accounts on Grok are free. Jump on in and you can learn how to use Scratch by doing these, or use them in the classroom with the students. Again, free for students in years 3 to 8. We have 4 courses that cover the Australian curriculum from students in years 3 to 6. And that's a way of sort of, I guess, adding layers around the sandbox that is Scratch and giving you more opportunities to teach coding concepts rather than just using Scratch as a sort of playground or a place to experiment. It will bring the coding concepts into context and teach them explicitly. So I would encourage you to have a look at that. So I'm now going to go back a little bit to the slides I skipped before. I was keen to get everyone's thoughts on the PRIM methodology, and thanks Jacqueline for saying that. I've found it really useful myself, actually. It's kind of the missing piece in some way to getting students comfortable with using Scratch. Okay. So when I talk about preparing for high school, I guess I'm talking more generally if you're teaching Scratch. For those in primary, you probably are very focused on your stage of the Australian curriculum and what you need to cover. It's worth knowing what's coming up in the future for your students. And Salome, yes, we'll share a link to the slides later. There's a general approach which is really reinforced in the curriculum, which applies right from the younger years all the way up to year 10. And it's a process around how you use programming with 3 steps. So specification is the first step, which is saying there is a problem that we want to solve. Now, out in the real world, that problem might be Uber saying we want to solve the problem of well-priced home delivery food. That's fine. For us in the classroom, it might be, I want to solve the problem of creating a maths game for my younger brother or sister. There's an infinite number of problems, but in the context of the curriculum, step 1 is to think about a problem. Step 2 is to plan a solution for a problem. And this is where we talk about algorithms a lot. So what set of instructions will solve that problem? So if my problem is that I want to make a sandwich, and if you've seen James do this in previous webinars, when we get to planning a solution, what do I need to do to make a sandwich? And we break it into pieces. We get bread, we put the butter on it, we spread the jam, we put another piece on top. And specification is where we get to coding. This is where we jump into Scratch or any other programming language and build a solution. Now, in primary, there's often a big temptation to jump into coding and go, let's learn to code, without having those 2 prior steps of specifying a problem and coming up with a set of instructions to solve it. So in Scratch, when we're exploring the blocks, we might not have a problem in mind and we might not have a set of instructions that we're then trying to code around. But certainly when your students move into years 7 and 8, this will be the process that they are learning. And we want, more importantly than knowing about which block does what, we want students to be able to start thinking about how they can solve problems using technology and to start being familiar with this process. And so to prepare students for the later years of the digital technologies curriculum, it's great to start this process very early. One thing I've seen used really well in primary school are things like B-bots, where students have a problem. I want to get the B-bot from one side of the map to a spot on the other side, and that is their problem definition step. Then the instructions, they might work with pen and paper to think, my B-bot needs to go forward, left, left, and right to get to a destination, and then they code the B-bot. So when we use Scratch, we want to start this approach with the students and start with a problem and think about the instructions and build it up. Because that process, if you can start that with your students in years 3 and 4 and upwards, that's a great preparation for what they need in the upper years. And again, how can we wrap skills and context around Scratch so that students learn this process rather than jumping straight into the coding? This is a picture to explain sort of what often happens in Scratch. So with Blockly or Python, you'll have quite a systematic approach. You will be working your way through steps to solve a problem and reach an endpoint. Scratch thinking, I've often seen looking more like the picture on the right, just a big of ideas and interconnecting lines and let's just go crazy and create. There is a place for that. I don't want to be down on the creative side of Scratch, but if I come back to what I said at the beginning, if you're using this to teach the digital technologies curriculum, you want to move your students over time to a process and a way of thinking that's more like the picture on the left, less like the one on the right. If you have free time, if you're doing Empower Hour, things like that, and you want the kids just to go for it, the right is fine, that's no problem. But if you've got precious class time, let's aim for the one on the left by using approaches like the PRIM methodology. Let me catch up with my notes and check that I'm covering everything. Okay, we're ready to talk about the curriculum. If you made it to last week's webinar, we broke these content descriptors down into really great small steps so that you could see exactly what coding looked like at different points in the curriculum. But really, if you're teaching primary, there are two content descriptors that cover what your coding teaching should include. That's okay if these words just look like a whole bunch of words on the screen, no problem. Digital solution is a Scratch project. A visual program, that means you're using the Scratch language, you're not typing instructions. Using algorithms, so coming up with that idea of having a set of instructions that you want to implement in your coding project, and involving branching. So anytime your students use the word if, if I click on something, do this. If my score is greater than 10 points, then do that. That's where branching comes in. And user input. If I'm pressing something on my keyboard, or if I click on something, that is where your user input comes in. This is the gold standard of sort of what primary school coding looks like. And for year 5 and 6, the only real difference, the extra word in there is iteration, repetition. So you saw in my PRIM methodology project that idea, repeat 10 times. And that was an example of repetition, iteration. We went over that instruction 10 times. And that's the key difference between year 3 and 4 and year 5 and 6. And for high school teachers on the call, of course, you can have a look at Scratch in the high school years. If you're teaching to the Australian curriculum, you'll see that they talk about general purpose programming language, which means a typed in language like Python. But we're in a transitional stage, I would say, for students. So if for your students, the best way for them to understand these concepts is using blocks, I would use them definitely. And the complexity of the coding, I'll show you in an example now. So there's a little bit of repetition here if you were with us last week, but I will keep it very brief. There's a link which Penny's going to share in the chat. There's a Scratch project here. It's not a very fun project, but what it does, it breaks out all of the aspects of coding that you need to understand and sort of be across to teach primary school coding, and just explains what those things are. So these little sprites, if you follow them through in order and start with sprite 1, this project shows, oh, there's a typo there, an example of sequential coding. So coding when there's a set of instructions, top to bottom, in order, things happen one after another. Every time I run it, the same thing happens. And that is a digital solution, and I am using visual programming. So in terms of curriculum coverage, I'm on the way for year 3 and 4, but I don't yet have branching or input. My second character shows you in Scratch what branching looks like. And it's this block here, which says if. So we start to make a decision. If the weather is rain, take an umbrella. On we go. I won't go through this in detail because we did that last week and there is a recording available of it. But if you're interested, you can jump into this project. And if you're thinking, what does iteration look like? You can see examples of all those concepts in this Scratch project. And user input, you can see here a little block that says ask. So everything you need to do in the curriculum is there in Scratch. It's just that you need to know where to find it and how to approach it. Okay. So as I've moved the order around, we have some projects we'd like to show you, but one topic that comes up frequently is assessment. And I think there were a couple of things I wanted to talk about with assessment before showing some more examples of coding. The key from my point of view in terms of primary school assessment of coding would be firstly making sure that you're very confident with what these content descriptors are saying and what you're looking out for, and then picking out which parts of those content descriptors you want to assess to. So they're fairly brief in terms of what they say, but you might ask students to work on a project that demonstrates that they are across the idea of branching and user input. And so your assessment task obviously would be to want to create a coding project that showcases these kind of blocks and lets you have a look at them. You don't have to obviously assess the full curriculum in one Scratch project, but you do want to make sure that what you are assessing is connected to the curriculum that you're teaching from. So how do you assess them? Obviously, you can look at the projects and peek inside them. Let me get out from here. So any project that your students submit, you could obviously come inside and look at the code and see, I can see an flip here. And obviously it's the role for you, you can ask questions of the students, what is this block doing? And what would happen if the answer was something other than rain? And interrogate the understanding of that concept. The other thing I wanted to show you today is a website called Dr. Scratch. And Dr. Scratch is somewhat of an automated marking tool. Now, it's not specific to Australia, but what you can do is put a project into here, and Dr. Scratch will score you. So I just got 13 for that project. But what you can see in here, it's worth looking at. One really nice thing here is called bad habits. And it will look at a project and say, hey, duplicated scripts. So your students might have 2 bits of code doing the same thing within a project. And it's always good when you work on programming to make your code as efficient as possible and not to duplicate or potentially conflict. And then it's really good at pointing out, you know, if you're going to create a sprite, you should give it a name that can be used and repeated and not rely on things like sprite 1, sprite 2. It's better to name it cat, dog. So as you code, you can see what those sprites are doing. Then the assessment tool also gives you feedback on these features. So flow control, 3 out of 3, that's helpful. This idea, for the best one to drill into, maybe we'll look at this one. What I like about this website is it will say if you got 0 points for this, here is what we're talking about by this concept. Here's how you can improve your code. And so it will step through. If you got 1 point, it will give you feedback. Sometimes when we want to set a blocks, it's a bit bad grammar there, but never mind. It will suggest ways to improve your programming by using different structures in your code. So it's quite a helpful tool. I'd say probably for your students to have a look through, in actual fact, and they can have a look and see what tips they get from here before maybe working on the project again prior to submitting it to you. It's definitely worth a look. It's not one-to-one direct with the Australian curriculum, but once these concepts start to make more sense, you can use it as a really useful tool to compare projects and get some interesting feedback on them. Okay. I'm looking forward to talking a little bit less. What we thought we'd do with the rest of the time is show you a bit of the wow factor that is Scratch, just to give you some ideas. Any questions on assessment before I move on? I'm just keeping an eye on the chat. So if you do have a question about that, let me know. So, cool things you can do with your kids that will really excite them. We have a few projects to show. The first one is actually using my video camera. So I'll briefly stop sharing and jump onto another screen. And let's have a look at that one. Here. Okay. Can you see that, Penny?
Yep.
Okay, cool. So you can see my face inside a Scratch frame now, which is cool and weird. There's a video feature in Scratch, which is really fun to experiment with the students, and the sprites inside your project can react to what you are doing as the video input feeds into the project. So I will start my project and you will start to see snowflakes falling, and I can bat them out of the way. Now, this is super cool. It's using video input, and you get the idea. If you want kids to be engaged with programming and use input, which in this case is the video stream, and branching, if I touch the sprite, do something, this is a great way to go. I'm using snowflakes because I love snow, but turn that into a soccer ball and you'll have most of the kids in the room, you know, trying to head the ball away, turn it into, I don't know, puppies, kittens, whatever you like. But these kind of projects are really engaging with the students to work on. If we look at the code there, you could do this as a PRIM methodology if you wanted to, because you can see when I start, I go to somewhere random, I wait, and then forever, I turn on my video, and you can work through and see there's not a lot of code involved in this project to get a really great result that kids will enjoy making. You could build on this project and layer it in so many ways. You could add points, you can do all sorts of things. This would be a fun outline to start with. Just a little caution, I tried to get this working in my browser before and had some problems with it. I'm not sure if something's happening with the Scratch website, but anyway, all of this code can be copied and you can have a go at home. It's a really fun project to make. I'm going to stop sharing that now and jump back to my other screen and come to, let's have a look, this screen. Okay. Are you seeing the right screen now, Penny?
Yep, I think so. I'm seeing your slide deck.
Okay, great, thank you. Okay. Another question we get asked a lot and we have a bit of fun with is using makey-makeys. So I might actually just stop sharing for a moment. A makey-makey is one of these. It's a device you can plug into a computer and it basically overrides your keyboard. So that beeping you could hear was me overriding my keyboard, in fact. It's very easy for the kids to play with. They're about $60 or $70, I think. They don't have a long life. You tend to use them for a couple of weeks and then probably put them away for the next group next year. But what's cool about them, you can plug alligator clips on and turn all sorts of conductive devices into controllers. So you might have a cable coming out sticking into a lemon, which will conduct electricity. You might make a shield out of tinfoil. You might make square tiles for the floor out of tinfoil you can jump on. And then all the students need to do is be connected in some way to the ground bar at the bottom and touch the input, and they will be able to control their Scratch projects. So by way of example, let me show you back over here. A very simple makey-makey project. So here's my dog. Now let me get connected. So every time I press down on my makey-makey, it's acting like the space bar and it's keeping the dog up in the air. And then when I let go, the dog touches the ground and kind of shrinks. And now he's gone really small because he touched the ground too much. If we look inside there.
Can you share the Scratch slide as well, Nicola?
Oh, sure. Were you just looking at me then?
Yeah.
Awesome. Thanks. Okay, can you see the Scratch project now?
Yes.
Okay, let's have another look. I'll run it again. Okay, so here's my dog and I'm pressing on the space key on my makey-makey to keep the dog up. And when I let the dog fall down to touch the color green, he shrinks. So that's just a little interactive project. But if we look inside, let's have a look at our dog. This block here that says when the space key is pressed, our makey-makey overrides our keyboard. So when the makey-makey is pressed, I change Y by 10. That's the instruction that lifted my dog up in the air. This project here, these lines of code involve user input, which is pressing the key, and an if statement. So that's year 3 and 4 in code on screen right now. And you can plug in a peripheral like a makey-makey, and students will find that really exciting. And you can mix the time between creating the controller and creating the Scratch project. So that's a really nice, simple approach that students will, I'm pretty sure, enjoy working on. The next thing to show you is the microbit. So I'm going to unplug a microbit. You can see it saying the connection is lost. Pop a note in the chat to let me know if you have used microbits with your students. And I'm going to find my chat because it's disappeared. Here we are. Okay. Who's using microbits? Oh, you got to make it JCAR for $50, says Michelle. Thank you. Microbits are fantastic peripherals. They're small programmable computers which you can use in any number of ways. We actually have some microbit courses on the website. You can also integrate them with Scratch. Now this is a little bit fiddly in terms of you do need to have some software installed on the computer, so it takes a bit of planning. But let me connect my microbit. Okay, so the same game, this time with a microbit being used as a controller. And my code this time for the dog says, if the microbit is tilted back, then the dog will go up in the air. And then it says if it touches the color green, display an X on my microbit screen. So the communication works both ways, into the Scratch project and back out of the Scratch project with your microbit. So now I'm not sure if you can see me on screen. You can see my screen, I'm not sure if you can see me. My microbit's now controlling the dog by tilting it forwards and backwards. And again, in terms of WOW, this will be a great way to work with students and create a project that's a lot of fun. And again, when I touch green, my little puppy's going to shrink. But here we go. Okay, one more WOW project to show you, which when you create Scratch projects, you can integrate other things. And one of the things I love the best, Scratch now has a text-to-speech feature, so it will speak out loud, and a translate feature. So if we look inside this one, I've set up a couple of things in this project. A simple spelling test. So let's remember how I did this.
How do you spell dog?
Sorry, I was playing around with different languages. Let me just get myself back onto English. That was Welsh for anyone who's interested. Okay.
How do you spell cat?
Now, did that audio come through okay, Penny?
Yep, it sounded great.
Okay, so when I click on my...
How do you spell dog?
So I'm getting asked to spell something. I can pop in here and spell it. Let me just start that again, sorry.
How do you spell bat? Yes, well done.
Okay, so the fact that you can see the words on screen here, that's okay. We can hide those like this.
How do you spell cat? Yes, well done.
So now we have the option to have...
How do you spell cheese?
I'll leave that there. We can have code in the background and students can make projects for one another, which will let them hear audio and not necessarily see the words on screen. So you can create a spelling test if you want to, using this text to speech. You can do storytelling. You could create maybe sets of instructions for students that need some help with reading. There's a whole lot of things you can do with this add-on, which you can find in Scratch by clicking down here and choosing text to speech. Another really engaging feature in Scratch that you can make projects with students that they'll really enjoy making. And here are the translate blocks. So this makes use of Google Translate and lets us translate things into different languages. So I'm just going to check. I am on English here, that's good. I made some code that says, when I press the up arrow, I'll be asked a question on screen. I can set my language, speak, and then translate my answer into German. So let's have a look at that. Come back in here. Let me try that again. Okay.
Your message is, wie geht es dir heute?
Now that's an English to German translation, we think. It doesn't sound particularly German, but I can switch my language to German.
How do you spell dog?
Sorry, that's the other part.
Your message is, hallo, wie geht's dir?
Sounds better. Okay, so that's another example of Scratch being able to do very powerful things, which the students can learn to do using the key ideas in the curriculum, but in a way that I think they'll find super engaging. So I wanted to show you some of those kind of wow factor features in Scratch that you can have fun with. Just briefly before we get to question time. I'm going to skip that slide. A brief mention for a minute or two just about research, which is coming out about the use of Scratch, which I think is really interesting and definitely worth talking about. There are some academic papers looking at all of the projects that have been created using Scratch and what we can learn about how students use Scratch. And the news is pretty mixed, I'll be honest. When we look at the hundreds of thousands and millions of projects created using Scratch, a lot of them are very, very basic. That's okay if you're using Scratch as an animation tool, if you're exploring other people's games. But if you're hoping to teach programming using Scratch, things like if statements and repeat blocks are not very well used in Scratch. Whether that's because they're not being taught or whether it's because students don't spend long using Scratch and they move on quickly to other languages, that's a little bit unclear. But we can see, you know, if it's only very young users using Scratch, that's fine. But if we're wanting to teach more complex programming ideas to older students, that's a problem. That we do want to explicitly teach the key programming ideas, which we had a look at earlier. What that means for you as a teacher, I think, is that you really want to focus on the skills that you want to develop. You want to focus on the programming ideas and you want to explicitly teach them rather than the tool itself, and thinking that, you know, if we all sit down and look at Scratch, we'll pick this stuff up. The research, unfortunately, is that while the platform and the language itself has all of the complex features of a fully formed programming language, most users barely scratch the surface. And we want them to go a little bit further than they currently do. So I've put the authors of the research out. They've got a series of 5 or 6 papers now, really interesting stuff, going through all of the data they can find on Scratch. And so what does that get us to in terms of if we're using it in the classroom? How do we implement ideas to address some of those shortcomings? How can we encourage the deeper thinking? And I think for us as teachers, I've harped on enough about some of my thoughts about teaching, but other ideas, you know, what questions do you want to ask the students? How do we let them work with Scratch and develop their problem-solving skills? You know, what are you expecting that block to do? What project are you working on, and what algorithm are you following here? What solution are you working towards creating? Those kind of questions can bring the students back in towards where we want them to be in terms of creating useful projects in Scratch, and also encourage them to test their code and seek feedback and work towards an endpoint rather than just throwing the blocks together and then making something they're happy with and going, well, that's what I wanted to make. Can they do it the other way and set out with an end project in mind and create that? Definitely, I would say allow time at the end for students to customize things, and focus on the transferable skills. So don't get hung up on particular blocks in Scratch, but more think about the thinking and the problem solving skills that we're working on with students. So that as they progress through the Australian curriculum, they have those skills better down in those concepts and they can apply them in more sophisticated ways. It's just gone 5 o'clock. I would encourage you to look on our website. That was the last slide. This slide here, what I wanted to highlight was that when you find resources on our website, for example, if you're interested in the Scratch ones, you can see a bar here with circles, and this little green one's highlighted. To me, that's meaningful because I know the curriculum and how we index it. But more information. If you click on more information for any of our courses, you can see that we have mapped the courses across to the Australian curriculum. And for this course, anything highlighted in dark green is covered within the course. So you can see that for years 3 and 4, this first Scratch course covers everything except branching. And other courses cover those concepts too. So for this one here, this one has the branching in it. And so that's just a quick way for you to see what programming concepts are covered in our courses. And I think that was where I wanted to get us to in the hour that we had, was to talk through some approaches to using Scratch and teaching, to show you some cool projects that will get students excited, to link it back to the curriculum. I think we've done. Now, please, if you have any questions, if you need to dash away straight away at 5, I totally understand that. Please, I don't want to hold you up. Likewise, I'll hang around for a little while. If you do have questions and you want to switch your microphone on or put them in the chat, I'm happy to do that. I think I'll stop the recording of the webinar shortly, and feel free to stay and ask questions, or if you need to go, we really appreciate you coming along today and taking the time. We'll have a recording of it up on our website tomorrow, and we hope there's a lot in there that will help you in the classroom. Next week we have a webinar teaching, oh my goodness, Penny.
I can find it.
Next week's webinar is on teaching data collection and interpretation. So please come back and join us for that one.